This video is about our supposed spinning ball Earth and the supposed equatorial bulge. Okay, so now they tell us the Earth spins at 1,000 miles per hour at the equator. And this spinning is creating a centrifugal force strong enough to upheave the ground 14 miles high by thousands of miles wide all around the equator of the Earth. Okay, and not only is the equator bulging, but from pole to pole, the centrifugal force is causing that to squash. So all of this is said to be going on underneath us, right? All this ground, rock, dirt, and what have you, moving toward the equator, yet we're supposed to believe we're immune to this on the surface of the Earth, right? Everything's trying to move to the equator, and the ground is trying to spin off of the ball, yet on the surface we can see lakes like this. We can see bodies of water still as glass. This is a fraud. This is make-believe. This is science fiction. Okay, many years ago, somebody decided, or a group of people decided, to gaslight humanity and tell us this fantastical tale of a spinning ball. And this equatorial bulge is nonsense. But they did this so that we would doubt our senses and not trust our senses. And so then you have to look to the high priest, the scientist, to give you a sense of reality. And they will define your reality and tell you what's real. Even though we say, we don't feel this motion, we don't see this motion manifesting on the Earth. We see no such disturbance. Bottom line is this: you can't have this centrifugal force manifesting inside the Earth, right, below us, below our feet, to the tune of 14 miles high, thousands of miles wide, gazillions of tons of dirt, being moved and the poles being flattened, and not have that same force manifesting on the surface of the Earth. Done. Case closed. That's it. What I just said there is 100% right. It's 100% fact. It cannot be manifesting in the Earth and not at the surface of the Earth. If the Earth is bulging, that means everything's trying to fly off. But you might say, yeah, but it's like standing on a mountain, and we don't fly off a mountain. Well, a mountain was formed by completely different mechanisms. The equatorial bulge is formed through centrifugal force. This is what they tell us. And it's linked to the rotation speed. Here's what Wikipedia says. An equatorial bulge is due to the force exerted by its rotation. And it says the Earth is ductile, which means malleable, right? It's flexible. The Earth's equatorial bulge has been decreasing in step, there's the key, in step, with the decrease in the rate of rotation. So that means if the Earth speeds up, the bulge gets bigger. If the Earth slows down, the bulge gets smaller. So for all those who like to say that, well, the bulge happened when the Earth was being formed. Well, you can't say that, or you have to change Wikipedia and all the science books, okay? But even if I give you that and say, okay, yeah, all right, it was formed when the Earth was being formed. Well, they say the Earth was rotating at 1,250 miles per hour at the equator instead of 1,040. Not much difference. So the Earth would still be bulging now, and the water and everything would still be rushing towards the equator. And so what this is telling us is we are under this centrifugal force, a centrifugal force powerful enough to bulge the Earth upwards of 14 miles, yet miraculously doesn't affect us here on the surface of the Earth. You can't stand on an Earth that's bulging due to a centrifugal force that can pull the ground up 14 miles by thousands of miles wide. We'd fly off. Okay, let me just restore some common sense and sanity. You can't live on a ball. We'd fall off.
Sailing around the world.
All the way around?
Yes.
What did you do at the bottom? Did you fall off?
No, I held on tightly.
Wow!
You can't live on a spinning ball, for sure. And you most definitely can't live on a spinning ball that's creating an equatorial bulge of 14 miles high by thousands of miles wide. That's a catastrophic, cataclysmic event. We'd all be dead. No life on this thing. And here's a little video I did to show what it might look like on this ball Earth as all the water rushes to the equator, matching the ground underneath, where the poles are flattening and the equator's bulging 14 miles high. The Earth would probably sound and look a lot like this. the Earth doesn't have a skin on it. And so what I want to show you is I took a water balloon, right? And I spin the water balloon. The water balloon has a skin on it. Okay, now why is the balloon bulging? For the same reasons that this fake, concocted, manufactured, oblate spinning spheroid would bulge for. The balloon is bulging because the contents of the balloon, the inside of the balloon, the water, wants to fly outward, wants to spread out, fly out, and it wants to fly off at the equator. That's why it bulges right in the center. Now, when we look at this other spinning ball, now this is a porous rubber ball, and I soaked it with some blue water so we could see the water fly out. Now, when I spin this ball, the water inside the ball immediately starts to spin out. As soon as the ball starts to move, this is a catastrophic, cataclysmic event if you're living on that little ball. Okay? If you're microscopic and you're living on the ball, that's catastrophic. Anything that makes the water want to fly out. Now, why is the balloon bulging? Like I said, the balloon is bulging because the water is trying to fly out. It's the water pushing against the latex of the balloon that's causing it to bulge. All right. Like I said, the Earth has no skin, and the rubber ball on the right also has no skin. And so you would see, if the equatorial bulge were real, the water would be flying everywhere. And even if the Earth did have a skin, the surface doesn't. Where we are, we have open lakes and water and oceans and ponds. And remember, water is the most easily disturbed, right? Of all the other substance on the Earth, water would show any movement. And yet, we can see water like glass still all over the Earth, even though it would all want to be running towards the equator. And we would fly off because the ground below us is essentially flying off 14 miles high. But they'll say you won't feel or notice any of this because of gravity. No, gravity's losing the battle.
Gravity?
Is it magic?
Not exactly, Pepper. In simple terms, gravity equals g times m divided by radius times 2, where g is the gravitational constant.
So, it's magic?
Yes, it's magic. Right!
Between centrifugal force and gravity, it's centrifugal force that's winning because the ground is bulging upwards 14 miles high by thousands of miles wide. Tons and tons and tons of rock and dirt and earth. So of course we would feel this if it was real. So to say that we could live on the surface of the Earth and have still lakes and be totally unaffected by this is bunk. It's baloney. It's garbage. This is a stupid model, and if you stop and think it through, you see how ridiculous this is. You know, this is part of their model. You know, a lot of times they'll say, well, you can't feel it rotate because it's only one rotation in 24 hours. Say, well, I don't care what you say. You have an equatorial bulge associated with your model that says the centrifugal force is strong enough. I mean, you have the Earth rotating at 1,000 miles per hour at the equator, so it's apparently strong enough to upheave the ground 14 miles. This is what their model claims. This is stupid. We've been gaslighted by this. Our common sense has been put on hold and put off to the side and scrubbed and thrown into the garbage so that we could believe this garbage, right? Because we know the Earth's not moving. And they'll say, oh, well, you know, how could you feel one rotation in 24 hours? Look at the hour hand on a 24-hour clock. That's moving once in 24 hours, right? Do you think you would feel that? And, of course, you'd have to say, well, no. But what they're not telling you is that the hour hand starts at the center of the Earth and shoots out to the equator. And at the equator, the Earth's radius is supposed to be 4,000 miles. So at the equator, the hour hand is now moving at 1,000 miles per hour. Would you feel that? Well, I would think so. But then they like to say, well, it's like you're in a car and you're driving 60. Do you feel that motion? Or if you're in an airplane doing 400, 500 miles per hour, do you feel that? But, you know, you might say, well, no, I don't feel that. But let's back up a second. The ground feels it. The ground is bulging outwards 14 miles, bulging up, straight up. I mean, that's higher than any aircraft flies, 14 miles high in the air. You know what I mean? This is silly. And yet this is what the model, this is what we're told we live on. What we really experience is this: lakes and water like glass, calm. This is impossible. Because like I said, as soon as the ball starts rotating, this ball, the rubber ball, the water starts flying off. And right there is a cataclysmic, catastrophic event. Okay, so now if we take this same water and we put it inside a latex balloon, now it has a stretchy skin, right? So it can bulge. So the fact that it's bulging tells you that everything wants to fly out, wants to fly away from the center of rotation. Okay, so now when we look at the Earth, they say the Earth is bulging. Well, if the Earth were bulging, that means everything wants to fly off. So since we see lakes like this, calm like glass, that proves right there that this is not happening. This is a fraud, right? So why wouldn't we fly off at the surface? Of course we'd fly off. We are further away from the center of gravity. The center of gravity is where it's the strongest, so it would be the weakest, the furthest away from the center of gravity, and that's where we are. So the 14 miles of ground below us have a stronger gravity than we have. So we fly off. We're gone. And number two, the centrifugal force is weaker for the 14 miles of ground below us, but stronger at the surface because it's further from the axis of rotation. So less gravity to hold us down and more centrifugal force to throw us off. So again, we would fly off. Now let me talk about this right here too. All water would be moving toward the equator, as I've showed you in the spinning ball. You can see all the water spinning off. And this is how it would work in the ball model. So gravity all pulls to the center. Now, when the Earth was first formed, it was a perfect sphere because gravity wants to pull all masses, big, large masses, into a perfect sphere. This is what they tell us. This is the theory. But as soon as it started to rotate, it started to bulge, and it disfigured the Earth a little bit. Okay, so as you can see, the axis of rotation, everything wants to go outward at a tangent, or tangentially to the axis of rotation. But gravity wants to go into the center of the Earth. So you can see the only place right here where the equator is, the equatorial bulge is going out and gravity's pulling in. That's the only place that there's a little bit of equilibrium, you could say, right? Which it's still not. That's your maximum place you're going to fly off the Earth. But at least the two forces are aligned with each other. But everywhere else, as you can see, gravity, you start to get an angle between the centrifugal force direction and the gravitational direction. So you would never have still water anywhere on the Earth. All the water would want to rush to the equator. This is cataclysmic. It would be a catastrophe. Bye-bye, ball. Okay, thanks a lot. And we'll talk to you soon. Thanks for tuning in. Bye. And here's the kicker. That would be a 2,000 mile per hour fluctuation in overall orbital speed every 12 hours. That's how you know the Earth's not spinning and it's not orbiting the sun. Hey everybody, P-Brane here. Well, do you feel it? Do you feel the Earth moving? You know that the early part of January is when we go through perihelion, and in particular, we go past periapsis. That's where the Earth is closest to the sun. It's traveling at its fastest orbital speed, and it's negotiating its tightest turn, all while spinning. So do you feel it? Do you feel this ride we're on? No, of course not, because it's fictitious. We're not moving. Okay, so let's sit back, relax, and let's break this apart. I want to talk about the motion of the Earth today. Every year, there's a point where the Earth gets closest to the sun, and early January is when that happens. Now, they pin it down to like January 2nd, January 3rd, 4th, something like that. So this is the time of year. So this is where the Earth will reach its maximum orbital speed while simultaneously negotiating the tightest turn, which is periapsis. And that's defined as a pivotal point of directional change in an ellipse. Well, first let me just say that there's two components to the argument of whether or not the Earth is flat or whether or not the Earth's a ball, and it's whether or not there's any motion to the Earth. I want to talk about motion because motion helps corroborate either the ball or the flat Earth. And being that we feel no motion can be detected. As you all know, anybody who's honest, if we say, is there any motion? Do you feel motion to this Earth? Of course not. We never have. But we should. I mean, we should, in light of the fact that the Earth feels the rotation, right? The Earth is said to be bulging 14 miles high, gazillions and bazillions beyond measurable tons of Earth, dirt, rock, water, bulging up at the equator 14 miles high, and the Earth is said to be flattening at the poles. The centrifugal force generated by the rotation is said to be doing this, and the bulge is tied to the rotational speed. So the orbit around the Sun also would generate a centrifugal force. But where's the Earth distorting features attributed to the orbit? I mean, it also generates a centrifugal force, so you have both centrifugal forces acting at once. So also, the equator, every 12 hours, would have a 2,000 mile per hour fluctuation, and those living on the equator. I mean, that should cause the ground to heave and hoe, especially as the Earth is whipping around, and the equator that's on the outside should be bulging out, and then as it goes to the inside, it would relax, and the ground would just be pulsing in and out. I mean, this is ridiculous. Because when you're on the outside, you'd be rotating in the orbital direction, and you'd have to add 1,000 miles per hour. When you're on the inside, you're rotating against the orbital direction. You'd have to subtract 1,000 miles per hour. That's a 2,000 mile per hour fluctuation every 12 hours, every day of the year. You don't believe this is a concept? Well, let's look at how a hurricane operates. Okay, a hurricane, you could think of it as a spinning, orbiting Earth. And let's say this storm has 100 mile per hour rotational speed. Well, it also has a linear speed, or the speed that the storm is moving relative to the ground, right? It's forward progress. That speed, let's say, is 20 miles per hour. On the right-hand side of the storm, you'd have a 120 mile per hour wind, because you have the 100 mile per hour rotation plus the 20 mile per hour speed that the storm is moving. You add those together. Okay, on the left side, the winds are rotating against the orbital direction, if you will. You subtract the 20 mile per hour forward speed of the storm from the 100 mile per hour rotational speed, and you get 80 miles per hour on the left-hand side of the storm, the much weaker part of the storm. Clearly, this would have an impact on the Earth and its inhabitants if, in fact, we were orbiting and rotating.